Welcome back. In the second half of this lecture, we're going to be talking about solving quadratic equations by completing the square and also by using the quadratic formula. Completing the square, the name for that actually comes from this idea that if you had this expression x plus this number and it was all squared, if you were to actually square it out, you would be left with this. You would be left with something where there's an x squared term and an x term, and then there would be a constant term. The completing the square business comes from often we'll have the x squared term and the x term, and what we want to do is complete that square. Find out what is the extra constant amount that needs to be added in so that what we have could be factored as this perfect square, x plus a number all squared. So that's our idea here. And so the thing to notice, for us to be able to complete the square, the constant that we're looking for, that we're going to be adding in, is found by taking the coefficient of the x term and cutting it in half and then squaring it. That's our process for figuring out what is the amount that needs to be added in order to complete the square. Once we've completed the square, then we know that what we'll have should factor out as x plus half of the coefficient of the x term. So if the x term had a 6 in front, when we did our completing the square, it would complete to x plus half of 6, which would be 3, all squared. Now, I've got this written out in symbols, which is probably not the easiest for everyone to understand. And this is the more abstract way of explaining what's going on. But I'll say some things in words, and then we'll actually work through an example, and it'll make things a little bit more clear. The idea that we're going to work with is, if we've got ourselves an equation, we've got it already written with everybody on one side and 0 on the other. And if we're looking at the business of completing the square that we started talking about, the x here didn't have any coefficient in front except for 1. So that's the first move that we'll make here, which is out of the x terms, we'll factor out the a so that we've just got the x squared term and then the x term. And so what we do next, we complete that square, and we complete the square by taking the coefficient of x, which is b over a, cutting it in half to give you b over 2a, and then squaring it. So this is the completing the square part, where we take that coefficient of the x term, cut it in half, and square it. Now, if we're adding that into our equation, we'll have to balance that out by also subtracting it from our equation. And we always do it in that order, adding first, then subtracting after. So take our x coefficient, cut it in half, square it, we add that, and then we subtract that. At that point, we just need to then recognize that what we have for the first 3 terms is now a nice perfect square. And then we can use our square root property to help solve the equation. We can help solve the equation by isolating for x and then using our square root property. So let's see this in action. I've got an equation here, a quadratic equation, 3x squared equals 1 minus 4x. And so first thing I'll do is I'll rewrite it with everybody on one side. 3x squared plus 4x minus 1 equals 0. Okay, so the first thing that I'm going to do is factor out the 3 just from the x terms. The 1 is not going to be part of this, so I'm just going to leave it alone. But from the first 2 terms, I'll factor out 3. Okay. Now that I've done that, the next part is the completing the square part, and I'm just going to doodle here on the side that if you were looking at that coefficient of x, that 4/3, we're going to have to take that 4/3 and cut it in half. So if we did that, half of 4/3 would be 2/3, and then once we've cut that in half, we'll need to square it to give us 4/9. So 4/9, that's the amount that I'll be adding in and then subtracting. So I have 4/3 x plus 4/9 minus 4/9. And we always complete the square first adding the amount in and then subtracting after. So when we've done this completing the square process, taking our x coefficient, cutting it in half, squaring it, then adding it in, those first three terms now can be factored out as a nice perfect square. Those first three terms factor out to be x, and then the half of the coefficient of x, so in other words, plus 2/3, whole thing squared. The 4/9 and the 1 are just coming along for the ride here. There we go. And you can confirm this. If you want to check on the side, pause the video and take a moment. You can see that if you were to take x plus 2/3 and square that out, take x plus 2/3 times x plus 2/3, you do indeed get x squared plus 4/3 x plus 4/9. Okay, so what comes next? I would like to be able to isolate my x, and so that means I need to get this 4/9 and this -1 out of here and move to the other side of the equation. I'm going to do one thing first, which is notice that the 4/9, the -4/9, happens to be inside this bracket, and that bracket is being multiplied by 3. So really, that -4/9 needs to be multiplied by 3. So if I want to take that 4/9 and have it leave the bracket, when it does so, it's going to be multiplied by 3. So we'll just rewrite out what we have now. The 4/9 is going to leave that bracket. And when we do, it's going to be multiplied by 3. -4/9 times 3 is -4/3. All right, so next thing I'll do is, on the next slide, I'm going to take these constants, -4/3 and -1. I'm going to move them to the right side of the equation. And then use my calculator to find that 1 plus 4/3 is 7/9. Nice. Now sorry, 7/3. I got ahead of myself. I know where I'm going. So on the next step, I'm going to isolate my x by now taking the left side and the right side of the equation and dividing them by 3. So when I do that, that'll get rid of the 3 that's on the left side of the equation. And 7/3 divided by 3, that is 7/9. So now we have perfect square equals to 7/9, and that means that we can use the square root property. We can say that x plus 2/3 is equal to positive root of 7/9, or x plus 2/3 is equal to the negative root of 7/9. Now, we can simplify this a little bit, because root of 7/9 is root of 7 over the root of 9. That's the same thing as root of 7 over 3. So the only thing now left for me to do is just solve for x, and I can do that by simply taking that 2/3 and moving it to the right side of the equation. So I'm just going to add an extra page on here, and we have then that x is, so we take what we have and we're going to be moving the 2/3 to the other side. So we'll have moving that, we'll have that x is equal to root of 7 over 3 minus 2/3, or x is equal to negative root of 7 over 3 minus 2/3. And since the denominators are the same for these fractions, I can actually combine them and make one fraction. So I could say root of 7 minus 2 all over 3, or negative root of 7 minus 2 all over 3. So for my solution set, positive root 7 minus 2 over 3, and the other solution, negative of root 7 minus 2 all over 3. Wonderful. Now this is a little bit messier looking as far as a solution goes, but again, this is the exact solution. We don't want to give decimal answers. We would like to have our solutions as exact as possible. And although this is a little bit more of a pain to check, you can still check your solutions in exactly the same way that we did before. You can find that if you did substitute in root of 7 minus 2 over 3 for x in the original equation, it will make the left side and the right side equal to each other. And same thing with the other solution. Okay, so the quadratic formula, and this is a formula that we can use to solve quadratic equations with a couple of cautions. The first is, for the quadratic formula to be applied, we have to have our quadratic equation already written with everybody on one side, 0 on the other, before we start identifying a, b, and c. So before you start identifying the coefficients of the x squared, x, and constant terms, you'll need to first have the equation rewritten so that everybody is on one side. The second one is sort of an obvious one to point out, but worth mentioning. It's called the quadratic formula because it only applies to quadratic equations. If you happen to have an x cubed or an x to the power of 5 or some other higher power, then you cannot use the quadratic formula to solve the equation. The third thing is more about being careful with our writing. There's a couple of places where people's hasty writing let them down, and one is in the fraction line. Some people will write the formula down and be most of the way there, and then do this, where the fraction line doesn't appear to cover both parts of the numerator. It looks like, the way that I've written it here, that only this is in the numerator, but that's not correct. The numerator has to cover, the numerator consists of the negative b as well as that square root. So that's one place where things can go astray. The other place where people can make mistakes is with the square root. Sometimes I'll see people doing this because they're in a little bit of a hurry and their square root sign doesn't quite cover everything. It doesn't quite cover the 4ac. So when people are running things through their calculator, they're not including this as part of the square root. And that is also wrong. So be careful. When we're using our quadratic formula, b squared minus 4ac, all of that is inside the square root. And all of this, negative b plus or minus root of b squared minus 4ac, that's all the numerator for our quadratic formula. Now, one other thing to note here is that the inside of this root, b squared minus 4ac, that's called our discriminant. The discriminant can be used to tell us what kind of solutions do we have. So even without working out what the solutions are, you can calculate via the discriminant whether this is going to be an equation that has two different real number solutions, or one repeated real number solution, or no real solutions. And it depends on, is the discriminant positive, in which case two real solutions that are different. If it's 0, then there's only one real solution. And if the discriminant is negative, well then there's no real solutions because you'd be taking square root of a negative, and that's not a real number. So if you're thinking strategically, I usually think about first factoring because that's the faster way to go. And if factoring doesn't appear to work, then I will think about one of the other two options, either completing the square or the quadratic formula. The quadratic formula will always work. It can be a little bit of a pain. And one other thing to remember here is that since there are square roots involved, we're going to need to make sure those square roots are in simplest terms, as we always do. So we want to find the number of solutions to this equation, and then we'll solve the equation. So first I'm going to bring everybody to one side. 3x squared plus 2x minus 7 equals 0. And so in this case, now that I've got everybody written on one side, the values of a, b, and c are 3, 2, and negative 7. So my discriminant, which is b squared minus 4ac, that would be 2 squared minus 4 times 3 times negative 7. And if I were to run that through my calculator, I would find that that is 88. So since the discriminant is positive, that tells us that we're going to have two different real solutions. Okay, so now what are those real solutions? We know, or at least we're expecting, that there should be two of them. So away we go. Now, if you're looking at this, if you tried to solve it without using the quadratic formula, if you tried to solve it via factoring, you run into problems in a big hurry, because you'd be looking for numbers that multiply to give you negative 21 and which add up to give you positive 2, and unfortunately there's no nice integer values that make that happen. So if you try to factor this, it's not going to factor. So even if they hadn't told us to use the discriminant, if there wasn't that hint there making us think about the quadratic formula, we'd probably wind up there anyhow. So I'll just need to add on an extra page. And now away we go for solving. We had the equation was 3x squared plus 2x minus 7 equals 0. And we've already identified what the a, the b, and the c are. That a is 3, that b is positive 2, and c is negative 7. So if we're solving, x should be negative b plus or minus the root of b squared minus 4ac, and the whole thing is over 2 times a. Now, conveniently enough, we already calculated the discriminant, and we found that that was 88. So we already know what's going inside of our square root. What's going to go inside of our square root is 88. And then for the next two parts, negative b, since b is positive 2, negative b is negative 2. And 2 times a. A is 3, so 2 times a is 6. Now, we're not finished yet, because of course we need to ask ourselves, is that root of 88 in simplest terms, yes or no? Are there any perfect squares that can be taken out of 88? And the answer is yes, there are. 4 goes into 88. 4 is a perfect square. 4 goes into 88 22 times. So that 4 could leave the root. So now we have negative 2 plus or minus 2 times root of 22, and everybody all over 6. And here, one last final move before I state my solutions. I notice that in the numerator, 2 is a factor of both of the terms, and 2 is a factor of the denominator as well. In other words, I could divide everybody top and bottom by 2. And so now I have negative 1 plus or minus 1 root of 22 divided by 3. So notice here, since 2 is a factor of those whole numbers, of negative 2, of 2, and of 6, then I can divide them all by 2, leaving me negative 1, positive 1 times root of 22, and 3 in the denominator. So my solution set is, I have -1 plus root of 22 all over 3, and I have -1 minus root of 22 all over 3. And those are my two solutions. Okay, one little word problem to work through. We've got a rock that's being thrown upwards from a position 10 meters above the ground. I'm going to start making a little bit of a diagram here. So I guess if we're 10 meters above the ground, we're maybe standing on top of a building. And so the ground position, I would consider that to be 0. So S, which is our position above the ground, would be 0 when we're at the ground. And here at the top of our building, that's 10 meters. So there's our position is 10. We're taking this rock and we're throwing it up in the air, and then it's going to have gravity come into play and it'll eventually start to fall down and hit the ground. So we've got two questions that we want to address here. The first question is, when will the rock hit the ground? Or in other words, when is the position equal to 0? We also want to know, will the rock ever reach 50 meters above the ground? So we're wondering, can S ever be equal to 50? That's the question that we'll want to address. So we'll start with the first part, which is, when does the rock hit the ground? Now, one thing to note here before we start doing any calculating is that we're going to be reporting our answers to 3 decimal places, which means that although, yes, we're going to be using, in this case, the quadratic formula to help us solve, we're not going to leave our answer with square roots. We are going to, in this case, grab our calculators and run things through to find out what the values are approximately. And this would be a typical case of when you would want to know what the approximate value is for word problems, because it wouldn't be very useful if you told somebody, oh, the distance is square root of whatever. People would like to know in terms of decimal numbers. So we want to know, for part A, when will the rock hit the ground? Or in other words, when is position S equal to 0? So that's what we'll do. We'll put in 0 for S and solve for T. So we've put in 0 for S. And away we go. So we've got it written already now with everybody written on one side of the equation with 0 on the other. We have our A, our B, and our C that we can identify. And if we felt like it, we could calculate out what our discriminant is, which is -b plus or minus, our discriminant is b squared minus 4ac. If you were to calculate that out for these numbers, b squared minus 4 times -4.9 times 10, that gives me 821. So I know already, yes, there are going to be real solutions, and apparently there's going to be 2 real solutions. And so we're going to have to think about that as we go forward. But let's continue. Our solution should be -b plus or minus the root of the discriminant, b squared minus 4ac, all over 2 times a. And if we were to put in our values for b and for a, that would be -25 plus or minus the root of 821 over -9.8. Now, running that through my calculator, I get 2 different answers. One answer that I get is when I take -25 plus the root of 821 over -9.8. That gives me -0.37276, so about 0.373. Or the other solution is -25 minus root of 821 over -9.8, and that's positive 5.4748 and so on, so 475. Now, if we're thinking about this problem, t is representing the time after we throw the rock in the air. And so the first solution actually doesn't make any sense, because this would be 0.373 seconds before we threw the rock. Somehow it's on the ground. This we're going to reject, because for this scenario, the time only makes sense if it's positive. So that means that, yes, our rock will hit the ground, and there will only be one answer for when does it hit the ground. It hits the ground after 5.475 seconds. Now, same thing as we did back in section 2.3, that we're going to need to write out our solutions in terms of a word problem. In terms of a sentence. So I'm going to just scroll down here. Maybe I'll do it on the next page. There we go. I can say that the rock hits the ground after approximately 5.475 seconds. And just as always, for any word problem, not only are we going to give our answer in terms of a sentence, but we're also going to use appropriate units. Here, time was being measured in seconds. So if we go back to the original problem, we notice that speed or velocity was being measured in meters per second, and that the time was being measured in seconds, and distance is being measured in meters. These are all things we should be thinking about before we start solving our problem. So we've got that our answer then, the 5.475, that's how many seconds after we release the rock does it hit the ground. And so the answer is the rock hits the ground after 5.475 seconds. Now, for part B, the question was, does the rock ever reach 50 meters above the ground? So the question is, can S ever be equal to 50? So let's find out. If we put in 50 for S, what happens when we try to solve for T? So here I'm putting in 50 for S. And if I solve for T, before I do that, I would bring the 50 to the other side. And it's a nice quadratic equation. So same thing as before, I would think about solving using the quadratic formula. I've identified what A, B, and C are, and just as before, I'll think about my discriminant first. Do we have any solutions at all? So my discriminant, which is b squared minus 4ac, if I were to use these numbers that I have, 25 squared minus 4 times negative 4.9 times negative 40, and I run that through my calculator, that is equal to negative 159. And so that means that there are no real solutions. So if you think the rock can reach 50 meters above the ground and you're trying to find out when does that happen, we've just found out that it doesn't happen for any real number. So the conclusion that we can draw, since there are no solutions to find when the rock is at 50 meters above the ground, then the rock never reaches 50 meters above the ground. And there we go.